Hi, in this video I'm going to take you through the solution of this complex numbers question, which I took from the CIE June 2017 paper 33, and it was question 11 in that paper. It says that the complex numbers u and v are given by u is equal to 1 plus 2 root 3i and v is equal to 3 plus 2i. In an Argand diagram, u and v are represented by the points A and B. A third point C lies in the first quadrant and is such that BC is equal to 2AB and angle ABC is equal to 90 degrees. Find the complex number Z represented by C, giving your answer in the form x plus iy, where x and y are real and exact. I encourage you to pause the video at this point so that you can attempt the question, and when you're ready you can come and compare your solution against mine. Welcome back. I hope you had some success, and if you found Z to be equal to this here, Z is equal to 4 root 3 minus 1 plus 6i, then that was the correct answer. If not, don't despair. We are going to go over the question together. I am going to draw a diagram here to represent the information that we are given in the question. So all the numbers that we are given lie in the first quadrant, so I'm not going to draw the negative x's. So if this here is your imaginary x's and this is our real x's, then I'm going to plot the point A, which represents the complex number u here. Let's suppose that's 1, and that would be 2 root 3, and the point is A. The complex number v is represented by the point B, so let's suppose B, if this is 1, then 3 is going to be somewhere here, so let's say that this is point B, which represents the complex number v. C is also in the first quadrant, so it is going to be, say, somewhere here. Let's call this one point C, which represents the complex number Z. Now, before we solve the question, I want to draw our attention to the fact that the angle ABC is going to be equal to 90 degrees. So if I were to join those points together, this angle B is going to be at 90 degrees. In the question, we are given that BC is going to be equal to 2 lots of AB. Now, using the position vectors of the points A, B, and C, I will know that the vector B to C is going to be equal to the position vector of C minus the position vector of B, and this is going to be equal to OC is known or is given as Z in the question, and OB, the vector OB, is given as the vector V, so it will be Z minus V. Similarly, the vector A to B is going to be equal to OB minus the vector OA. Alright, and what is OB? OB is going to be the vector V minus OA, which is the vector u in this particular case. Now, please note that this expression 1 and this expression 2 are both complex numbers, and these two complex numbers, complex number 1 and complex number 2, are perpendicular to each other because we are told in the question that they meet at 90 degrees. Now, we need to find this relationship that links these two complex numbers. We know that if we multiply a complex number by I, then the effect of that is going to be a counterclockwise rotation of that particular complex number. For example, if you don't remember that, if I am given Z is equal to, say, 2I, then IZ is going to be equal to I multiplied by Z, which is 2I, and this is going to be equal to minus 2. Alright, plotting this on an Argand diagram means that I'm going to have on the imaginary axis 2 and on the real axis I'm going to have -2 here, and you can see clearly that the angle between these two complex numbers is going to be equal to 90 degrees. Additionally, you can see that this original complex number 2i has been rotated by 90 degrees in an anti-clockwise direction to set it on to -2. Similarly, this line BC can be rotated onto AB by multiplying this complex number BC by I. Except in this case we are told that for these two to be equal, then AB has to be multiplied by 2i. So the factor that we have to multiply AB by is going to be 2i. So BC, which is Z minus V, is going to be equal to 2i multiplied by V minus U. It should be downhill from here because we know what V is equal to, and we also know what U is equal to. So I'm going to substitute those complex numbers in and then just solve for what Z is equal to. So Z minus V, which is equal to 3 plus 2i, should be equal to 2i into a square bracket V, which I've just found to be 3 plus 2i minus your 1 plus 2 root 3i. This is how U has been defined in the question. And then we're going to go ahead and solve this. It tells us that Z minus 3 minus 2i is going to be equal to 2i into brackets 3 plus 2i minus 1 minus 2 root 3i. I'm now going to collect like terms and say that Z minus 3 minus 2i is going to be equal to 4i minus 4 plus 4 root 3. Okay, and the final step then is just going to be grouping the like terms again, taking everything from this left hand side and isolating Z is going to tell us that 4 root 3, and then it'll be minus 4 plus 3, it's going to be minus 1, and 4i plus 2i is going to be equal to plus 6i as before. I trust that you found this video to be useful. Thank you for watching. Cheers.